Okay, so objective 3 is using the properties of inverse functions to find exact values of certain composite functions. This is going to be pretty mind-bending, so you may want to watch and listen to this more than once. So we're going to use the same properties that we reviewed in section 1.8. So we know that if you do the sine first and then do the inverse sine, you get back to where you started. And if you do the inverse sine first and then the sine, you get back to where we started. So in the first equation, the domain, let's see, sine of an angle. The first equation, the domain is the negative pi over 2 to pi over 2. So your x has to be in negative pi over 2 to pi over 2. But in the second equation, you're doing the inverse first. So that has to be between negative 1 and 1. Those are the only numbers we can find inverse sine of. And then once you do the sine, you're going to get a number as the output. So your x value has to be between negative 1 and 1. So x is jumping back and forth here between being an angle and being a number. So you have to keep in mind which one it's being. So we're going to work on these exercises in class together because it's kind of tricky. Okay, so let's look at the inverse cosine function. If we look at the graph of the cosine function, again, we see that it fails the horizontal line test infinitely many times. So again, we need to do a domain restriction, but do you see how the domain restriction needs to be different? Here's 2 pi, here's pi. If I do negative pi over 2 to pi over 2, I'm going to still have a piece that fails the horizontal line test. So for the cosine graph, we restrict the domain. Whoops, this is pi. This is pi over 2. This is 2 pi once through the cycle. We restrict the domain to 0 to pi, endpoints included, so that we have a one-to-one function. So this piece right here, we start at 0 and we go to pi. So 0 to pi, that is the domain of the cosine function that we use so that it has an inverse function. So the inverse cosine function will only be defined in quadrants 1 and 2. So in the same way as with the sine function, we find the inverse function by we say, let's say y equals cosine x, then interchange x and y. So then we say x equals cosine y, and then we solve for y by applying the inverse cosine function. So y equals the inverse cosine of x, and I suggest that you read it that way, the inverse cosine of x. And this x must be between negative 1 and 1 to be able to make sense of this. So y equals cosine inverse of x means x equals cosine y. These are interchangeable statements. But the x needs to be between negative 1 and 1 because it's the output of a cosine function. And the y needs to be between 0 and pi because that's how we would define the restricted domain. So we read y equals cosine inverse of x as y is the angle in quadrant 1 or 2 with a cosine of x. So y is the angle, x is the number. Okay, so if we use our chart, hopefully you're getting really fast at making this chart. 0, pi over 6, pi over 4, pi over 3, pi over 2, 0, 1/2, root 2 over 2, root 3 over 2, 1, 1, root 3 over 2, root 2 over 2, 1/2, 0. So we can use our chart to find what is the inverse cosine of 1. So again, you're working backwards. You're finding here is where the cosine is 1. At what angle does that happen? It happens at 0. And then what's the inverse cosine of root 2 over 2? Here's the root 2 over 2 in the chart. Read backwards to say the angle at which that happens is pi over 4. So in the same way, the inverse cosine of 0 is going to be pi over 2. And then let's think about how this is going to work with the inverse cosine of negative 1/2. Because if you're thinking unit circle, you're going to say, where is the cosine equal to negative 1/2? And you're going to come up here and you're going to go, oh, that's the angle 2 pi over 3. Because we have to be between 0 and pi. And then where is the cosine negative root 3 over 2? That's going to be at 5 pi over 6. Okay, so we'll work together using our calculator to find these approximate values. So do make sure to bring your calculator class on Monday. And then similarly to the sine function, we have the inverse cosine function applied to the cosine function gives us x back, but the x needs to be between 0 and pi here when you're doing the cosine first. If you're doing the cosine inverse first, this number needs to be between negative 1 and 1. So we'll work on these examples together because they can get kind of tricky. And then here's the inverse tangent function. Here we need to restrict the domain, and we want this piece here where it's 1 to 1. So it's from negative pi over 2 to pi over 2. But in the case of the tangent graph, we can't include the endpoints because the function is not defined there. But look at how similar it is to the domain restriction for sine. So how I remember these is sine and tangent are related since the tangent has the sine in the numerator. So the domain restrictions are very similar. And the reciprocal of sine is cosecant. So cosecant has a similar domain restriction. The endpoints can't be included because of the places where it's undefined. So it's almost the same as for the sine. So for the inverse function, we have the range is going to be negative pi over 2 to pi over 2. But look at the domain. The domain can be any real number. So that's quite different. So I want you to practice reading this math statement as y is the angle in quadrant 1 or 4 with a tangent of x. And I want you to practice writing that. So f inverse of f of x can be written tan inverse of tan x, and that's x. And here the x has to be between negative pi over 2 and pi over 2. And then if we do it in the other order, and we're doing tan inverse first, then x can be any real number. So notice again that this is very different than the inverse sine and inverse cosine. So let's use our chart again, and we'll work on these in class together. And then we're going to do some solving inverse trig function equations. And you're going to want to isolate the inverse trig function. So this one you're going to want to divide both sides by 2 and get pi over 2 and say, well, I can do the cosine of both sides. And the cosine of pi over 2 is 0. So the solution to this equation is x equals 0. So when x is 0, that's a solution to this equation. So let's look at this one. If we divide both sides by negative 6, then we get sine inverse of 3x equals negative pi over 6. So you're going to do the sine of both sides. And say 3x equals the sine of negative pi over 6. So sine of negative pi over 6 is negative 1/2. And then you're going to multiply both sides by 1/3 and get x is negative 1/6. So that is the solution to this equation. And we'll work on these other two together in class.